we're looking at some triangle properties here. We're starting this new section with the perpendicular bisector. And what it tells us, well, first, if we have this segment, I'll call a segment, I'll call AB. We have the perpendicular bisector. So I'm going to say this line here in pink. I'm going to call it line L. It's a perpendicular bisector. That means it intersects here at a right angle, and that means that it bisects it. It means that it cuts it in half. So I'll call that point right there X. All right? Now, what this theorem, the perpendicular bisector theorem, tells us is if I pick any point on this line L, I'll pick this one up here, C. It means that no matter what point I pick here, it's always going to be equally distant from those two endpoints. So no matter what, I'm going to always have that AC would be congruent to CB in this case, and I would also have what we were given from the beginning, that AX was congruent to XB. So this part in pink is based on the perpendicular bisector definition, and in green here it's based just upon this theorem that we're talking about. So how are we going to use it? Well, if we're given this picture right here, this line M is a perpendicular bisector of PQ. Well, what that means is, because it's a perpendicular bisector, they must be equal to each other. And because of the bisector theorem, we can then say these two sides are equal to each other. So we can easily just fill in, if PS is 55, it means QS also is 55. If QT is 30, that means PT also is 30. Now PQ is this big long segment, so we'll just use segment addition. PT and TQ are each 30, so that means the whole big thing is 60. So that's how we do those. Now, in this problem, same thing. We'll say this is a perpendicular bisector. Our theorem tells us then these two segments must be equal. So we'll just set them equal to each other. 2x plus 9 equals 7x minus 18. When we solve this, we end up with 5x is equal to 27. That means that when I do that division, x will equal 5.4. And if I want to know what one of these side lengths is, say I want to know what QR is, well, all I would do is I would plug it right back into the formula to find what that value is. And so when I plug that back in, I would get that RQ is 7 times 5.4, and subtract 18, I should get 19.8 for those. Now, it's not just enough to know what to do with it. We also will be trying to find what the equation of some of these lines, or this perpendicular bisector is. So here's what this would look like for a segment AB. We would look at, well, if it cuts in half, it would probably be about right there. Something perpendicular should be something like this. So what do we need to know first? For an equation of a line, we need a point. In this case, you want the point right in the middle. That's a midpoint. And then we also need to know, for a line, we need to know its slope. So, starting with the midpoint, just because we'll start with the midpoint. The midpoint I can always find by doing an average of the points. So, the average of the x values would be -1 plus 3, and then divided by 2. Same with the y's. 6 plus 4 divided by 2. That means my ordered pair should be, I should end up with 1, 5. And if we look here, it should make sense. Yeah, based on our rough sketch, 1, 5 appears to be about right. Now, finding our slope. First, let's find the slope of segment AB. The slope of AB would be the y's minus the x's. So I'll subtract the y's. If I did 6 minus 4, I got to do -1 minus 3, which means my slope here should be 2 on the top and -4 on the bottom, which means I have a -1/2 as my slope. Now, the slope of a perpendicular line, we need to do two things. We need to take the reciprocal of this slope with the opposite sign. So the opposite sign will make it a positive number, and 1/2 will flip it around to be 2/1, or just 2. So that's the slope we're going to use. So now we need to find what the equation actually is. And to find what the equation is, we're just going to start by saying, well, y equals mx plus b, like we've done before. Plug in what we know. Our y value we just got from our point, so 5. Our slope is this slope we just found, 2. X is from that point as well, and we want to find b. Well, in this case, b is just going to be 3, because 2 plus 3 will give me 5. So my final answer, my final equation, it needs a y, and it needs an x. My slope stays the same as 2, and my b value I just found. Y equals 2x plus 3 is the equation that I want. And that's how we do these problems with these perpendicular bisectors.